Today our lesson is going to be how to join and separate angles. When we think about joining angles, I want you to think about adding angles together. Two angles will equal the total number of degrees in an angle. For instance, in our example, the distance between A and C using angle ABC is 72 degrees. The distance between C and D, angle CBD, is 48 degrees. When we put those angles together, we know the entire angle measurement is 120 degrees. We can also separate angles by thinking about subtracting. If we know that a total number of degrees, say, is 120 degrees, and I know one of the angles is 48 degrees, I'll be able to determine what's left by taking 120 minus 48. $72 degrees remains. We'll look at a couple different angles to join and separate. If we know the angle measurement of angle A, B, C in each of these questions is 130 degrees, we are going to separate into two angles in two different ways. If I know one angle measurement is 90 degrees, but I know the total degrees are 130 degrees, I'm going to subtract 130 degrees minus 90 degrees to find the angle measurement of ABQ. ABQ is our unknown angle. If I take 130 minus 90, that will determine that the angle measure that's left is 40 degrees. As we look at question number 2, angle ABC still measures 130 degrees, but our angle that is known is 75 degrees. Let's take 130 degrees minus 75 degrees to find the angle that's missing, TBC. When I subtract 130 minus 75, I know that the remaining angle is 55. In order to check our answers, we could join a 55-degree angle with a 75-degree angle, and it should equal our 130-degree angle. Let's add to find the measure and join angles that are shown. If we look at two separate angles, I have JKW. I want to join with WKL. Those two angles together, by adding 30 degrees plus 45 degrees, will determine the measuring angle of the entire angle JKL. Putting them together, we know that the missing angle is 75 degrees. Even though our angle looks upside down, I know that I can join STH with HTU, a 75-degree angle, plus a 60-degree angle, to find the total measure of angle STU. If I add 75 degrees plus 60 degrees, I get an angle measure of 135 degrees. Here's a question about Rosie. In the following directions, she wants to build a model bridge. Rosie cuts a 90-degree angle into two parts. Let's start with a 90-degree angle, knowing that that angle is a right angle and it's perfectly measured at 90 degrees. If she joins the parts to make the whole angle, what can you say about the sum of those two measures? Well, let's take a look. If Rosie joins two angles together that make a right angle, what kinds of angles would those two be? We talked about three types of angles as we classified. Are they acute, obtuse, right, straight, or reflex? When we look at those angles, they measure less than 90 degrees, so we know that an acute angle plus an acute angle can equal a 90-degree right angle. If we were to use a protractor and draw a 90-degree angle on a piece of paper, let's just do that off to the side here and label our angle A, B, C, remembering that the letter in the middle tells me the vertex where those two rays come together. If we would look at somewhere inside of A, B, and C, what could we do to draw a line BG? If we were to measure using a protractor and find the angles to record them, I know that the entire angle is 90 degrees. If I take a 90-degree angle and I think about two perfect angles exactly the same, what are their measurements going to be? Well, let's take that 90-degree angle and divide it in half. Using our road map, 2 goes into 9 4 times. 4 times 2 is 8. Take away, bring down, and repeat the process. How many times does 2 go into 10? It can go 5 times. Subtract. There's nothing to bring down. Each angle measure would be 45 degrees. There are other combinations which we could use. We could have an angle that measures 60 degrees. We could find out the missing measure if we needed a 90-degree angle. Remember, an unknown angle means take 90 minus 60 to figure out what is left. Another angle you might have is an angle that measures 35. If I think about a missing angle, but the two together equal 90, take 90 minus 35. Both of those missing angles we know should represent an acute angle, the first being 30. The next, use your borrowing skills and know that that missing angle is 55. Joining them together or taking them apart should not change the angle measures. If we use the measures in each of these parts of a circle, we're going to use our protractor to find the distance of each of those angles. One angle I know for sure is a 90-degree angle. If I look at drawing those parts together, I know that these two angles, O to N and N to this point, are not the same. However, I know this angle and this angle are identical. If we look at those two angles, I still know that these two must equal 90. If we say this one is 60 and this one is 30, there gives me my other 90-degree angle. So part of our circle is 90, part of it is 60, part of it is 30. If we add one more part, since we notice that these two are identical, I would need another 30-degree part. but I would have to know what the remaining half of a circle is equal to. That part I'm going to find by taking my half a circle, straight angle, minus 30 degrees. If you're looking at classifying angle M, we know it's obtuse, we know it's greater than 90. If I use subtraction and I separate those angles, the other part of my circle is 150. Knowing what we do about circles, the total distance around from start to finish is 360 degrees. If we think about two angles that measure 135, one angle measures 45. I'm going to look at what other angle measure I would need in order to find the missing angle. We know that we have an entire angle that measures 135. I'm going to take the 45-degree angle away in order to find the missing part. We know that what's left is a 90-degree angle. If we classify that in one other way, we could say the measure of the other angle is right. A perfect 90-degree angle. The last two questions tell us add to find the measure of angle ABC. If we write an equation, 46 plus 34, I will know angle ABC. 46 plus 34, that angle measure is 80 degrees. We could also classify it as being acute. We know it's acute because it measures less than a 90-degree angle. Based upon our image, that angle falls smaller than the 90-degree line. If we look at number 2, we must look at the entire angle QRT, remembering that this is a straight angle. I'm looking for the distance between T and Q, which must be an obtuse angle. But I must also remember that a straight angle measures 180 degrees, like a half of a turn. 180 degrees minus the part that we know will determine the measure of angle TRQ. 180 degrees minus 85 degrees. The missing angle is 95 degrees and it is obtuse. You will begin working on your rotations for today, task cards on your own, and IXL.